Hello everybody, Matt Davis here with some more homework quiz help. This one is coming from section 7.3. Suppose that NBA player Kobe Bryant's true average points per game is 25.3 with a standard deviation of 8.133 points. We are interested in estimating his true mean points per game using a random sample. So for samples of size 24, suppose that a value of x bar equals 21.87 is found. What is the sampling error? Round your answer to 2 decimal places. All right, so the first thing, in the interest of giving help but not answers, we are going to change the value of x bar they gave us. So instead of working with that one, we're going to use x bar is equal to 22.46. After that, it's a matter of translation. So some key things, they want to know what is the sampling error. So when you have sampling error, or they want to know what specifically is the sampling error, you want to take the difference between your sample value and the population value. So in this case, we're working on averages. We have a sample average and we have a population average right here. So they said his true average points per game. So that's mu. So we know x bar and mu. So how do we get to sampling error? Well, let's take a quick look at the formula sheet. If you look at the chapter 7 line, and you go all the way across to the right, you see sampling error equals the absolute value of x bar minus mu. So that's what we're going to use right here. The chapter 7 line all the way to the right, SE equals the absolute value of x bar minus mu. So let's go back and write that down. In the context of averages, sampling error is equal to the absolute value of the difference between the sample mean and the population mean. So it turns out this is a really easy, fast problem if you go the right direction, because all we have to do here is subtract and take an absolute value. So plugging in for x bar, we have 22.46 minus the population mean 25.3. If we do the subtraction on that, we do get a negative. We get negative 2.84. And then the absolute value would get rid of that negative sign, so it would just be 2.84. And that's going to be our answer. So again, like super fast, right? So how come so many people missed this that I needed to make a video for it? It's probably because they went in the wrong direction. And the reason you can go in the wrong direction is because sampling error comes up in other contexts. We get asked things like, what is the expected sampling error, which is a different question. That's when we haven't taken a sample yet, and before we take it, we're wondering how much error should we expect. In this case, we've already taken the sample, and they want to know how much error did we get. So when that's what they want, we just go to this formula right here and plug in. So we do need to know the sample value and the population value, but both of those were given. Another context where sampling error comes up is what's the probability we get a certain amount, an acceptable amount of sampling error. So again, the tricky thing here is translation. We have 3 different settings where sampling error comes up. We just got to make sure we pick the right one. And fortunately for us, when we pick the right one here, it's nice and fast problem. So I hope that gets you on the right track and that you head back and do this one quickly, easily, and correctly. Good luck to you.